Hello students. So in today's lecture we are going to study about constrained motion. So let's take a very basic example. Suppose that this is ground and here one block, let's call it block 1, and one string is connected to another block, let's call it block 2, and some force is being applied on this block 2 in this direction. So due to this application of this force F, the block 2 will start to accelerate in this direction. So it will start to move in this direction and it will pull the block 1 2. Let's assume that there is no friction on the ground, frictionless, complete frictionless surface. Now here velocity of block 1 and velocity of block 2 both will be related to each other, or we can say acceleration of block 1 and acceleration of block 2 will be related to each other, or even in term of displacement, how much block 1 and block 2 will be displaced on the ground will be related to each other. So their acceleration, velocity and displacement is related to each other until this string became slank or loose. So by the time when the string is still taut, these two acceleration, velocity and displacement will be related to each other. This is called constraint. Constraint means relation between acceleration, relation between velocity, relation between displacement of two or more than two particles. Or we define constraint in one more way, like see, until string is loose, until string is taut, it became loose. In that time, this length, which is length of the string, is L. So distance between these two blocks will be L. Distance between, we can write distance between 1 and block 2 will be L. It cannot be less than L or more than L. It will be L. Why? Because the string is still taut. If it became loose, then it will be less than L. But until the string is taut, until it became loose, the distance between these two blocks, block 1 and block 2, will be separated by a distance L, which is a constant quantity. So we will define constraint by two things. One, relation between acceleration, velocity or displacement, or we can say some limitation, some constant quantities, some constant quantity, or we can also say some limitation. This some constant quantity can be also defined as some limitation, like these two blocks cannot be separated by a distance more than L because they are attached with a string whose length is L. So distance between these two blocks cannot be more than L. So the motion of these two blocks are restricted such that distance between them cannot be more than L. This is constraint relation here. So constraint can be defined as a relation between two or more acceleration, velocity, displacement, or some constant quantity, some limitation. Constraint word actually means limitation, restriction. Like suppose that this is two-dimension plane and some object is moving on this your screen is take your screen as two-dimension plane and some object is moving on the plane. Or let's take this is x-axis, this is x-axis, actually, and take this as x-axis, this is y-axis and this is z-axis. Suppose that some object is moving in this two-dimension plane, this is two-dimension plane, xz plane, some object is moving in xz plane. Can we say that y coordinate of the particle is limited? This object cannot go inside the plane. Like this, take this plane as ground, this is the ground, xz plane is in ground and y coordinate is perpendicular to ground. So if any object is moving on ground, can the object go inside ground? No, object cannot go inside ground. So we can define that here y coordinate of the particle will always be greater than equal to 0 if it go above the ground, if it jump. So this is also a type of restriction. Y coordinate of the particle can never be greater than 0. It will be either at, sorry, actually this is wrong, less than, okay, it was correct. It will always be greater than 0, not less than 0. So y cannot be negative, y will always be either 0 or positive. We can take many example like this. Suppose that we have a hemisphere. hollow hemisphere kept on ground, and some insect is here inside hemisphere. An insect is trying to crawl inside the hemisphere. So from the center, distance of the insect will always be r. If this radius of this hemisphere is r, I mean hollow hemisphere is r, the distance of this insect from this center point will always be r. It cannot be greater than r, it cannot be less than r. So here we can write distance from O will always be equal to r. This is also a type of constraint. So whenever any motion is limited or two motion is connected with each other, this is called constraint relation. This is called constraint relation. Now we will study three types of constraint generally. So we can write types of constraint. Types of constraint. Types of constraints. So first type is either rod or pulley. Two objects are connected by rod or two objects are connected by pulley. Both are same thing. Only difference is rod can pull and push both. Tension and normal both can be generated in a rod. But pulley can only pull anything. Only tension can be generated in a pulley. So we'll study both of them together. Second type. Sorry, actually this is not pulley. What I have written. String, not pulley. First type is rod and string. So only one difference, rod can pull and push both things, but string can only pull any object. So only tension can be generated in string, but rod can generate tension as well as normal. Second type is pulley, constraint related to pulley, and third type is wedge constraint. So these three types of constraint we are going to study. So let's start one by one. In this first lecture of on constraint, we will discuss constraint motion related to rod. So first we are going to study constraint relation related to rod. One very popular type of question is asked in this. Suppose that we have a this is x-axis and this is y-axis. X-axis is on ground and y-axis is along some wall. And suppose that we keep a rod here like this. We have a rod. Suppose that this is a rod. Now the question will ask, suppose that this rod started to slide down. Here friction is 0. Here also friction is 0. At both the place friction is 0. Completely frictionless surface. So this end will slide in this direction with speed. Suppose that u. So this end will come down. Suppose that it is coming down with speed v. When it will come down, this angle will change or remains constant. Suppose that at any time t, this angle is theta. The rod making angle with x-axis from a negative x-axis is theta. So now tell me, will this angle remains constant or change? Of course it will change. As rod will fall down, this angle will decrease. As rod will fall down, this angle will decrease. With time, this angle is going to decrease. Now at any time t, at any time t, at any time t, angle is theta. We are not changing the angle. Angle is theta. With time, angle will change. But at any time t, angle is theta. Now the question is, what is the relation between v and u? So first of all, we have to find the constraint thing. What is constraint here? We can think in both ways. Either we have to keep some quantities constant, or we will try to relate velocity of both the end, this end and this end. So let's solve the problem in both way. One, we'll try to find one restriction or one constant quantity, and in another way, we'll try to relate both the velocity. So method one, first method one. So in method 1, we will try to relate velocity of this end and this end. Suppose that at this stage, this angle is theta. This angle is theta. Now, when this end is going down with speed v, can we divide it into, or can we break it into two components? One component will be along the rod and one component will be perpendicular to the rod. Similarly, this is going in this direction. So we can also break it into two components. One component will be along the rod and one component will be perpendicular to the rod. Now this angle is theta, so this will be 90 minus theta. So if this end is going down with speed v and this is 90 minus theta, so this is going to be v sine theta. and this speed is going to be v cos theta. Similarly, this angle is theta, this is 90, so this will also be 90 minus theta. So this is going to be u sin theta, and this end will be u cos theta. Now tell me, the length of the rod cannot be changed. Just like we have seen one example here. Here this was connected by a string, or take it as rod. Suppose that this is a rod. So velocity of block 2 will be equal to velocity of block 1. Both block cannot move with different velocity. Why? Because they are connected by rod. So in the same way here, if we take this point, one end of the rod, and to other end of the rod, so their velocity will be equal, but not in every direction. Here also it is possible that this block is at rest and this block started to rotate in this direction. So we cannot say both block will be in the same velocity in all direction. Both block will move with same velocity in all direction is a wrong statement. Along the rod both have to move with the same velocity. Why? Because rod cannot be compressed or rod cannot be elongated. So along the rod both have to move with same velocity. So same concept will apply here too. Along the rod both have to move with the same velocity, because rod is a rigid body, and we all know in a rigid body distance between 2 points remains constant. Or along the rod the speed of this point and this point will remain same. So this point is moving with velocity v sin theta along the rod, and this point is moving with u cos theta along the rod. I'm not talking about the whole velocity, I'm only talking about the velocity along the rod. So from here we can say v, or we can say u is equal to v tan theta. This is the relation. Is this relation valid every time? Yes, but as theta will change, tan theta will also change. So relation between u and v will also change. Just think logically, when rod was almost vertical, the velocity of x will be less or more. And when rod is, so see in this condition, x will go more and v will go less, or v will go less, x will go more. I mean, not x, u will go more. So it will depend on theta. Like here, just you can take, as tan theta will increase if tan theta is more than 1. If tan theta is more than 1, means angle is more than 45 degree. If theta is more than 45 degree, tan theta more than 1, in that case u will be greater than v. Or if tan theta is less than 1, means angle is less than 45 degree, then u will be less than v. So relation between u and v will keep changing as theta will change. This is the first method, very simple, how we solve this problem. But this is not conventional method. I mean, here we are able to solve this problem, but we have to follow the conventional method, which will help us to solve even complicated problem. So let's solve the same problem again. This is our vertical wall and this is our horizontal ground. This is x axis, this is y axis, and this is our rod. This is our rod. At any time this angle was theta, this end will go down with speed v, and this end was going in this direction with speed u. Both of them were not losing contact. Now suppose that we take this distance as x, this distance we call x, and this distance we call y. Here we are using which concept of constraint? That something will be constant. Now tell me which quantity. First of all, we have to find which quantity is going to remain constant in this. So very simply we can say that the length of the rod, this length of the rod is going to be constant. Suppose that L is length of the rod is L. So either rod slide down, rod is vertical, rod is horizontal, length of rod is not going to change. So length of the rod will remain same. So in this we can clearly write, if this is x, this is y, we can write L square is equal to x square plus y square. Very easily we can write this. We just using Pythagoras theorem, x square plus y square is equal to L square. Now since L is constant, if we differentiate it with respect to right, dl square by dt is equal to dx square by dt plus dy square by dt. We are differentiating it with respect to time. and L square is constant. Length of the rod will not change with respect to time. So L square is always constant. So d square by dt will be 0. X will change with time. As rod will slide in right direction, this x is going to be increased. So when we'll differentiate dx square by dt, we will get it 2x dx by dt will become velocity. This velocity is not u, actually it is u, or just write dx by dt, and plus dy square by dt. When we'll differentiate it, we'll get it 2y dy by dt. But here dy by dt will be negative. Why? Because y is increasing. Derivative of not dx dt. Derivative of decreasing function is negative. So from here we can write 0 is equal to 2x dx by dt, velocity along x axis, this end is u, plus, or just write here, minus 2y v. Why we have taken here minus sign? Because dy by dt is minus v, not v, because y is decreasing with time. When we'll solve this, we'll get u is equal to y divided by x into v, or we can write what is y by x. Y by x is none other than tan theta. So we can write u is equal to v tan theta. Same result we have derived from the that theory. Velocity remains same, u is equal to v tan theta. Here also u is equal to v tan theta. So this is the approach how we solve question related to rod, question related to constraint in a rod. This is rod constraint. So many times this question is asked. One more thing sometimes asked, particularly in JEE Advanced life problem, what will be velocity of the midpoint? Somebody will think that midpoint will go down with some velocity. Midpoint will move in vertical axis, which is wrong. Somebody will think that midpoint will move in horizontal axis, which is also wrong. So what will be really the velocity of the midpoint of this rod? Let's solve that. Again, this is x-axis, this is y-axis, and this is our rod. This is our rod. Now we want to calculate velocity of this midpoint. We already know velocity of this is u, and velocity of this is in downward direction v. We have also derived u is equal to v tan theta. We already know, and this is the midpoint of the rod. So if this is x, we can clearly say this distance will be x by 2, because this is L by 2. So this will be x by 2, and similarly this distance is going to be y by 2. Y by 2. So this distance will also be y by 2. Now if we want to calculate what will be the vertical, I'm not saying velocity, only vertical component of velocity of the midpoint. So see, this distance was y, so velocity was v. So if this distance is y2, we can clearly say velocity of, if we call it point O, midpoint O, velocity of O in y direction is going to be u by 2. It is going to be u by 2. And similarly, velocity of point O in x direction is going to be, sorry, this is v by 2. Y direction was v, u by 2. Why? We can use midpoint formula. Or just if this distance was y, we dy by dt, when we differentiated y with respect to time, we got velocity of this point. So if this distance is y by 2, when we'll differentiate it, we will get v by 2, v by 2. So if this point is going down with speed v, the middle point will go down with speed v by 2. Either using differentiation or midpoint formula also we can apply here. And this point will go in this direction with speed u by 2, and this direction with v by 2. So velocity, net velocity of this point will be, can be at any angle. Some students sometimes think that this will be along the road. No, it is not necessary. It will be along the road only for some particular angle. Otherwise, it will be at some angle, not along the rod, not necessary. Now, velocity of O can be very easily written as root under Voy square plus Vox square. So, velocity of O will become root under V by 2 whole square. So, actually V square by 4 plus u square by 4, which will become 1 by 2 after going out root under v square plus u square by 2. What was u? We'll put the value of u. What was u? U was v tan theta. So we'll write here v square tan square theta. Tan square theta. So v of o is equal to 1 by 2. V will also come out. So we can write v by 2 and root under 1 plus tan square theta. Tan square theta. Or we can write v naught is equal to 1 plus tan square theta is sec square theta. So sec theta. So v by 2 sec theta. Sec theta. So this is the velocity of midpoint of the rod. We can also calculate the same in term of u2. I mean in term of u2. Like suppose that here we will not put the value of u, but we will put the value of v from this equation. So v is nothing other than u cot theta. V is equal to u cot theta. So if you put here velocity of midpoint, so 1 by 2 will go out, u will also go out, so u by 2 and multiplied by root under, here we'll get 1 plus cot square theta. Cot square theta. So here we'll get VO is equal to u by 2 into cosec theta. Cosec theta. U by 2 into cosec theta. So this is also correct. This is the velocity of midpoint. This is the velocity of midpoint of the, just one sec. This is the velocity of midpoint of the rod. So in this way we can calculate velocity of any point. This is for all of you for homework. Try to calculate velocity of different point on the rod when it will slide on ground. I hope you understand the how we have to deal with constraint question related to rod. In the next lecture we will discuss the questions related to string, and in third lecture we will discuss wedge constraint problem. Thank you. Keep watching, keep learning.